What are we doing? 2B. Here we go. To be or not to be. But all right. So I am splitting up. I'll tell you three right now. I'm sure others will be joining us in the next few minutes. I'm going to split up the next lesson. I'm looking at what Edmentum is providing for us for like the first lesson of Unit 7. And I'm going to make the executive decision to split that up. So think of it as a 2-day lesson. We'll be finishing it tomorrow. But I think there'll be enough here by splitting it in half to keep us busy practicing these concepts, getting ready for the whole thing tomorrow. Um, I thought if we did it all in one day, it would be too much, probably a little too crazy and overwhelming. So this is my attempt to make it a little more digestible. So if you check out what's in Edmentum for the first lesson, this is the name of it: Slope Criteria for Parallel and Perpendicular Lines. I think we're going to probably need some review, and I think it'd probably do the whole group a service if we take it slow. We got through the first unit pretty fast, Unit 6. So I'm going to hit the brakes. We're going to cut this lesson into 2 days and go from there, okay? So I will be taking notes, your notes, as your like homework, your assignment, your participation for today, just so you know right now. So if you're doing it on Google Docs, I get it. It's better than nothing. Do your best to take some notes because I will want to see those today. And if you don't have it ready for me at the end of the hour, you'll have to send me something to count as participation and like your assignment for today. Any questions on that, please? Concerns? Complaints? Not yet? Okay. Braden. Hi, Braden. Thanks for joining. Hello. Antonio, can you hear me, bud? Okay. Very good, sir. Thank you. All right, ladies and gentlemen, let's get started. So I've got some questions to get you for thinking about these concepts. So I'm gonna put a couple questions on the screen, like we've been doing the last couple weeks. I want you to think about it, and then give me your answer in the chat. And again, like usual, there's not really one one right way to say this. I'm not looking for like the answer. I'm just looking for what your thoughts are. How would you describe it? So our first one is, what is slope of a line? What is slope of a line? And how do you describe it or you think about it? How do you define it? Okay, well, we'll define it as a group in a sec, but I know you've all used it in the past. So take a sec and write to me how you think about slope. What do you remember about it? What do you know about it? How would you define it? I see one response. Let's hear from all of you. I know you all know something. How would you describe it? And I do want to do chat just so that folks aren't talking over each other. Oh, who is this? Is this? Oh, it must be Maria Celeste. Braden, I'm going to mute you, bud, just for now. If you do have a question, always feel free to turn it back on. But thank you. Just for now, I'm going to mute you. And Manaya, you too. Thanks, guys. Nothing personal. It's just the background noise. Okay, so I see you all wrote something. I'm going to just double check quick to see if all four of you do. Awesome. I see some good stuff. Hang on. Very good. How many units going up or down? How steep it is? Beautiful. How steep it is. Thanks, guys, for all of you sharing what you remember. And I couldn't agree more. It's basically how steep the line is. So I'm going to put that in as our answer to this. You guys already said that. That's kind of generic, how steep the line is. That's how I think about it. And then someone said exactly how many units up and over. So let's put that in as well for slope. I see another comment. Oh, Andrew, thanks for joining. You're not too late. So we'll use slope today. So I just wanted to get you started to think about it. So it's exactly how many units, because we'll be using it on the graph, right? Or with our points, our coordinates. And when we're using the graph or using the coordinates, we can tell for sure how many units it is, up and over, or down and over. That's how we measure slope. So we'll look at that in more detail in a sec. Thanks, guys and gals. All right, so next up, what are parallel lines? Parallel lines. And what does that mean for lines to be parallel? So just again, in your own words, your own thoughts, what do we remember or how would you describe parallel lines? If you could think about that and then answer to the best of your knowledge in the chat for me, please. It's in the name of our lesson, right? So before we just start using it, I want to go back with you and make sure we all have a better understanding about what parallel lines mean, just like slope. So just describe it to the best of your ability. What can you say about it? Not exactly one right answer. There's lots of ways to describe it. Okay, I've got 3 responses in the chat. Let's hear from everybody, please. Should be 5 of you. Or maybe 4 since... Good morning, Keegan. We're just getting started. Okay, so what do you remember or how would you define parallel lines? And then another way to think about it is what does it mean for lines to be parallel? Okay, let's see what we came up with. Someone said the same. Lines that are the same or close together. I like that. Similar to each other. Good. Similar. Good. So I'm seeing lots of good responses. And I agree. They are similar to each other. And some people said the same. Same what exactly? If I've got this line floating out in outer space, a line parallel would be, let's see what else someone added. Ooh, same length as each other. That's a good one. You're all on the right track. They're lines that are going in the same direction. So I'm just making a sketch here, a little picture, and they're a little wobbly, but the point is they're going in the same direction. Let's put that down. They go in the same direction. They have the same slope. If they have the same steepness, if they have the same up and over, up and over, up and over as each other, then that means they have the same exact slope number. So we can think about it in those 2 ways. They go in the same direction forever. Let me slow down my writing here. Go in same direction. And also, they have the exact same slope number or measure. All right. People adding still. Awesome. Aaron, I like that too. She said never cross. So if 2 lines are going in the same direction and have the same slope, something that follows from that is that they never cross. Look at my 2 lines I sketched out. If those are going in the same direction, and if you were to be able to back up and see the lines getting larger and larger and larger, right, on left and right side, up and down, they're never going to cross because they are going in the same direction. There's parallel lines all around us in our like architecture, in how we build things, how stuff is designed. Here's my notepad. What do you see there? Parallel lines, right? So you can write on it. Look around your room, wherever you're doing your class, there's parallel lines somewhere. Maybe in your windows, the two sides of the window are parallel lines to each other. Okay, and then last up, you're probably going to guess it, is perpendicular lines. I want to refresh what that means. So same question, but for perpendicular. Can you define in your own words perpendicular lines? What does it mean for two lines to be perpendicular? And I'll give you guys a hint. They cross, but it's a very specific type of crossing. Let me draw a little picture for this one. Again, it's just a sketch, so it's not perfect. It's very specific way to cross. And you probably know this instinctually in your head. You've used it before. You see them all the time in your room, in your life, in your world. You know the way we build things. Let me see what some of you guys are saying. Cross at a certain point, lines that cross, intersect at a certain point. All good responses, and we're going to expand on this. You guys are right. They do cross, and at in a certain way. They cross at a right angle. I'm going to add this into my picture. Please add it into yours as well. See that little square? That's a symbol that means they cross at a right angle. So for what are perpendicular lines? They're lines that cross at a right angle or at a 90-degree angle. At a 90-degree angle. Okay, same thing, right angle, 90 degrees. Good. They intersect. Wait a minute. Oops. Someone said the y-axis and the x-axis. Good. Antonio has a good example. The two lines that we use on our graphs all the time, the x-axis and the y-axis, one's going straight. Hang on. Let me draw this in. One's going straight up and down, right? Vertical, perfectly vertical, our y-axis. And the x line is going left and right perfectly. Therefore, the x and y axis are another example of perpendicular lines because they're meeting at a right angle. So we're going to live in a world for today and tomorrow and probably longer too, soaking up these ideas of slope, parallel lines, and perpendicular lines. Okay, I'm going to move on. I'll wait for 10 seconds on this screen if people are writing. Any questions, concerns about slope, parallel, or perpendicular lines? Okay, one last question I'm going to throw in here just to think about. At the bottom, perpendicular lines. They're crossing. Both of those examples, the lines are going in different directions, right? They're not parallel. Obviously, they're not parallel because they're not going in the same direction as each other. Do you think they could have the same slope, or are they going to have different slopes? The perpendicular lines, do you think they could have same slope, or are they going to be different numbered slopes, different steepnesses? Think about that. Type your answer in the chat if you have an idea on that. Couple responses here. Braden and Antonio, thanks both of you. If they're going in different directions, and slope describes like a line steepness, it's describing how high and over, high and over. Let's see in a moment what that means for the slopes of perpendicular lines. Okay, new page. All right, let's make a statement on the slopes of these two different types of lines. So at the top, we've got parallel lines, and at the bottom or below that, we've got perpendicular lines and their slopes. So again, let's put a little image up here. If two lines are going in the same direction, they're parallel. And what is slope again? It's the steepness of the line. And a couple folks pointed out it's exactly the units from one point to the next, up and over, up and over. It's the same amount up and over for the slope. So that means parallel lines like these two have equal or same slopes, equal numbered or same slopes. So for example, if these two lines I've sketched here, uh, if this has a slope of maybe 2, then that means the other line also has a slope m of 2. Side note, a reminder, I'm going to put this on our notes. We refer to slope as m, okay, little m. I'm going to do that for the rest of today. You're going to see it in Edmentum. You've probably seen it before. Good, folks. Thanks for answering that question about parallel lines. Now, perpendiculars, remember, they're crossing at a 90-degree angle. So this is where things get a little different and kind of special. Kind of interesting, I should say. These guys are crossing at a 90-degree angle. So I was hoping it stood to reason that they can't have the same slopes. Let's look at these two perpendicular lines I just sketched out. Change my color. So if one of them is going up and over to the right, the same amount each time, going up 3 over 1, up 3 over 1, up 3 over 1. Well, obviously, line number 2, if I've got one line, we'll call that line 1. The other one is line 2. Well, line 2 is not going up and over, is it? It's going down and over, down and over. So they can't have the same slope. And here's where things get kind of specific and special, I'm going to say. They have what's called opposite reciprocal slopes. Opposite reciprocal. You don't have to turn on your mics, but I want you to say that out loud with me a couple times. Opposite reciprocal. It's a big word. There's two different things happening here. Opposite means the positive or negative, and reciprocal means the flipped fraction. I'm going to add that in below, okay? That's what reciprocal means. It means flipped fraction. So for example, down below in my picture, if line number 1 has a slope of 3 over 1, and then remember, whenever we write a fraction with something over 1, we're going to simplify that to just the top number. Why? 3 divided by 1 is 3. So my slope for line 1 is 3 in my example. The opposite reciprocal of 3, we have to change the sign, so negative, and then you're going to flip it however it's given to you. So if the slope was 3 over 1 for line 1, the slope for line 2 is 1 over 3. Notice that the sign changes from positive to negative, and then the fraction or the slope is flipped, reversed. Top switches with bottom. They're crossing in a very specific way. They have opposite reciprocal slopes. Good. I'm glad you guys are seeing that. I'm going to hold on this screen here. We're going to use these concepts all day. Well, for the rest of this hour and for tomorrow. Let's take our time with this, okay? We have to be, we're going to practice this constantly, and I want you guys feeling comfortable by the end of today, and then even more so at the end of tomorrow, with the ideas of slopes, parallel line slopes, and perpendicular line slopes. We're going to do lots of practice. Okay, while we're waiting, are there any questions? Chat or verbally is okay. Awesome, Antonio. I'm glad you're feeling well on it so far. Let's do some quick, I'm going to throw in some quick practice questions with you guys right here. I'm going to make a box with some quick practice questions. We're going to keep the old stuff on the screen. Let's practice finding opposite reciprocal slopes, okay? So question 1. If I give you a slope of 2 over 3, What is the opposite reciprocal number for 2 over 3? You're going to change the sign and you have to flip the fraction. So what's the opposite reciprocal of 2 over 3? Anybody? Any ideas? Two things, change the sign and flip the fraction. I see one idea in the chat. I want to give you guys time to try it before I look and see your answers. I want to hear from everybody. I didn't write the question. The question is, what is the opposite reciprocal of 2/3, 2 over 3? Good. I see 3 of you have tried. 5 of you, awesome guys, or 5 comments at least. Good. The worst that could happen is we don't get all of it right. We're not going to learn if we don't practice. So I'm really glad to see you guys taking risks. I want to check and see what you guys are saying. Awesome. Negative 3 over 2, negative 3 over 2. Good. And some of you said positive 3 over 2. That's okay. Just remember, it's a two-part thing. We have to also change the sign. So it is negative 3 over 2. Look at those two numbers in the little box on the right. We've got positive 2/3 and then negative 3 over 2. 3 halves. Good. Good. Let's try another one. Let's try a whole number one because these can be tricky. All right. Question number 2. Okay. If I give you a slope of 5, what is the opposite reciprocal of 5? Tricky because it doesn't look like a fraction, right? But if we were to flip that and change the sign, what's the opposite reciprocal of just 5? Any ideas? Good. I see some responses. Keep typing it in. What do you think? Okay, let's see what you guys said. Good. Aaron, Sella, and Antonio, thanks you 3. And you all got it right. We remember to change the sign. Good job, Sella. You caught that. So if the first one given to you is positive, 5, we know the opposite reciprocal has to be negative. And then if it's a whole number like 5, if we flip that, it turns into 1 over 5. I think about it as like upstairs and downstairs. 5 is, there's no downstairs, right? It's just the number 5. So we're going to put that in the bottom of a fraction. We have to put it over or underneath 1. All right, there's 2 practice problems. Let's look at a more nuanced problem now. Okay, here we go. Oh, okay. One more thing before we jump into that, I want to go over this with you guys. So recall that straight lines can be written in the form below: y equals mx plus b. This, I know this looks familiar to all of you, those of you who were with me last year, and then whether any school, any math class you've ever been to in high school, you've done this equation before. What is this equation? This is the slope intercept form of an equation, form of a line, a function. And what do they stand for? Okay, well, we already know what m is, right? Whenever you see an m at this point forward in our math class, I want you thinking slope. So what does the m stand for? It's slope. What does the b stand for? It stands for the y-intercept. I'm going to label that. It's specifically where it's the y-intercept. Okay, a couple chats. Let me see what you guys are saying. Good, Sella, nice job. It's the y-intercept. And what does that even mean? What is the y-intercept? So I'm going to draw a diagram here to see what these things are. So please do this with me if you can. I think it was Antonio who mentioned the graph, the XY axes. So here's some XY axes, okay? And if I have some random line, any straight line function like this one right here, I'm going to make it purple to have some contrast. Here's our line. Okay, the slope is describing how up and over it's going. So it's basically m. If this was like 2 over 3, it would be up 2 over 3. Since we're doing this generically, I'm just going to write this as m. The slope is telling you how high and over to go to the next point. And where's b? It's right here. B is where your line is crossing the y-axis. So B stands for the y-intercept number, and that's where the line crosses the y-axis. We don't really care too much about the x-axis usually. It can be useful, but we use the y-axis crossing all the time. Where the line crosses the y-axis, okay? So we're going to rely on this slope-intercept form, y equals mx plus b, for our functions, our straight lines. In the chat. Good. Specifically, Antonio, it's where our function line, the purple line, is meeting the y-axis. Okay, now I think we're ready to try a problem from Edmentum. So I'm going to walk you guys through it. And I told you at the beginning, not everyone was here for this. I've taken our first lesson and we're splitting it up into 2 days, okay? Before we get to all the problems that you could see in this lesson, I wanted to kind of take it a little slower with these concepts as a review, as a reminder on how these ideas work. Parallel lines, perpendicular lines, slope intercept. Okay? And so let's do a practice problem now, unless there's any questions. Here we go. Okay. Here's our question. Yes, it is wordy. I understand that, but we have to be ready for wordy stuff like this too. Here we go. Write the equation of the line that is parallel to y equals 2/3 x plus 7 and crosses the point 1, 5. Okay. Write that down, and then we'll look at how to solve it and what it even means, okay? I want to try drawing a picture to see what it is that we know, what's going on here. They want us to write the equation of a line. They want us to write y equals mx plus b, but we need the correct b and we need the correct m. B and m. We need to know the slope of this line and the y-intercept of this line. And then we'll just put them in their spots for m and b. That's our main goal. But what ingredients do we have to work with? This line is supposed to be parallel to this line that they gave us, which is y equals 2/3 x plus 7. So I'm going to draw a little picture to see kind of what we know. A sketch, okay? It's not perfect, but it's just meant to give us an idea. So here's our xy coordinate plane. What does the line 2/3 x plus 7 look like? Well, we know the y-intercept is 7. So up here at 7 high, our line is crossing right there. And then we know the slope is 2 over 3. So that means I go up 2 and to the right 3. So up 2 units, right 3 units. And we could do another one, up 2 over 3 from our last point. So something like this. Now, granted, I'm making a sketch. It's not perfect, but it gives us an idea of what we're looking at. So that's how we can figure out what the first line looks like. Something like this. Okay, and it goes on forever both sides. We're supposed to write the equation of a line that's parallel to this purple line I just made, and it goes through, crosses through the point 1 comma 5. So in red here, this is an idea of the line we're supposed to write the equation for. It goes through 1 comma 5, so about right here. That's 1, 5. And there'll be a line that's parallel to my purple line. I'm going to just make it dashed. Like this. And they want us to write the equation of this red dashed parallel line. What is the equation, the y equals mx plus b for this red line? That's our goal here. And the purple one, just as a reminder, I'm going to label that 2. This purple one is the one they gave us, y equals 2/3 x plus 7. Okay, now we want to write y equals mx plus b, but we don't know what those numbers are yet, okay? You can make a picture like I did, and we might even be able to kind of guess the right answer from the picture, but it's best to be for sure. Like, what is the actual y-intercept number? It might be some weird fraction. So we have to go through a process to find the correct slope. We need the correct slope and the correct y-intercept. Slope is m, and the correct y-intercept is b. Okay, so how do we find this? I started today's lesson talking about slopes of parallel and perpendicular lines. If I want the slope to my red line, and I know that the red line is parallel to the purple line, do we know the slope of the red line just based on the equation for purple? Can we find it based on this purple line's equation? Remember, look at the equation they gave us. I'm going to box it in the word problem up here at the top. This is in y equals mx plus b format already. You see that? The 2/3 is our slope. Our slope, the slope we want for our red line, is going to be the same. I see some comments. Let me check what you guys are saying. It's going to be the same as the one they gave us. How do we know that? Because they're telling us our red line is parallel to the given line. So our slope is 2/3. Done. We've already found it. So I can put that in my answer over here on the right side. 2/3. However, we still need to know what is the correct y-intercept. What is the b number for our red line? Okay, here's how we're going to find it. We're going to take the generic blank y equals mx plus b equation. We know the correct slope, so let's plug that in. Our correct m number is 2/3. Now, x and y and b are still spaces to fill in our equation. We don't know b. That's what we're trying to find. Okay, it does look like, I know that I see where you guys are getting the 5 from. Notice that, let's look at the diagram on the right, my red diagram, my red line. We know from the words, from the word problem, that our line of interest that we're trying to write the equation for, it goes through 1 comma 5, right? I'm glad you guys are seeing that. That's the only issue, is that's not on the y-axis, right? It's a little bit to the right. It's 1 unit to the right here, 1 comma 5. So we're going to use that because our red line has an x of 1 and a y of 5. Though that is a point that lives on our equation. So since 1, 5 is the x, y of the correct line, we're going to plug those two values, 1 for x, 5 for y, into our equation in the middle of the screen where we're working. Y is 5. How do we know? Because they told us our equation goes through this point. X is 1. We don't know b. That's the whole problem. That's the whole point. We're trying to find b. Now it's just a matter of solving this equation for b. Now we solve for b. We do have a fraction. So this is a good practice for us to go back and remember how to deal with adding and subtracting fractions. So another reason I wanted to take it slower, because I know we're going to be doing a lot of this. Okay. So multiply the 1 times the 2/3. Now 1 is a good number because it's not going to change the other number we're multiplying, right? So 1 times 2/3 is just 2/3. Okay, now I want to move my 2/3 away from b. I want to subtract 2/3 from both sides. 2/3 minus 2/3, they cancel. Problem is, we've got 5 take away 2/3 on the left. So we're going to have to deal with this. How do we add or subtract the 5 and the 2/3? Well, here we want to subtract it, right? 5 minus 2/3. How are we going to deal with that? We need to turn our 5 into a fraction that has a 3 in the bottom. We need to have whenever we want to add or subtract fractions, they have to both be fractions with the same denominator. So look below here with me. We're going to multiply the 5 times 3/3. And I'm going to continue this in this box right here. Sorry about the space. Here's the problem continued and finished over here. So 3/3 times 5 minus 2/3. Okay, when we finish with this, we'll have our b. 3 times 5 is 15/3. 3/3 times 5, 15/3. Now I can subtract the fractions. 15/3, take away 2/3. We're just interacting the top numbers. So 15 minus 2 is 13. Our b value is 13/3. Excuse me. So we already knew m. Think back to the beginning. Back here on the left side, I'm going to circle or box it. We knew the right slope was 2/3 because we want the line that's parallel to 2/3 x plus 7. So we kind of stole that slope and used it. But that's okay because we know the lines never cross. They have the same slope. Then we plugged the slope of 2/3 and we plugged in our x and our y, 1 and 5. And we solved that equation for b, and we found it at the bottom. So now finally, we can write our equation for the red line that's parallel, and it goes through 1, 5. Here it is, our equation. Y equals 2/3 x plus 13/3. I want to really quick put these into Desmos so we can see them graphed like perfectly, not just me doing these sketches. I'm going to come back to this in just a sec. You guys can use this tool as well. I'm hoping that by now you all are. Desmos.com, free online graphing calculator. So you go to desmos.com and then click on this blue thing in the middle, graphing calculator. And you can use this to check your work and visualize your problems, your questions. So to graph both of these, I'm just going to type in the equations on the left side. Y equals 2/3 x plus 7. So there's our first line, the one they gave us. Here's our new one. First off, actually, let's type in the point, 1, comma 5. Here's the point they gave us right here. So remember, the goal was to write the equation of the line that's parallel to this starting red line, and it goes through 1, 5. Let's type in the one we just found. Y equals 2/3 x plus 13/3. Boom, look at that. The green line is cutting right through the 0.15, and it never crosses the red line. We did it. That weird b value of 13/3, that's right here. It's the y-intercept of our second line, of our green line. And these problems are not always going to have whole numbers because all these lines that exist aren't always going through whole numbers, right? It's not going through just 5 or just 4. It's in the middle at 4.3. 4.3 must be 13/3. Okay, that's it for this question. Any comments, questions about how this worked? Please let me know where you guys are at. Nothing? Okay.
Part seems pretty, I wouldn't say simple, but I'm tracking.
You tracking so far? Aaron, thank you for telling me. I realize it's a process and we have to mix our conceptual, right, within our algebra. Conceptual, what I mean by that is like parallel lines. We know they never cross. And that means we know they have the same slopes. That's what allowed us to steal and use the 2/3 slope, how we did that. And then we also relied heavily on y equals mx plus b, and we will continue to do that. So let's look at another example. We've got 15 minutes or so left. Here we go. This will be similar to what we just did. Write the equation of the line that is perpendicular to this line. Y equals -1/2 x plus 5, and it crosses through the point -4, -1. Okay, this time it's not parallel. This time it's perpendicular, so be aware that they're going to do that to us. They're going to mix it up. Sometimes they want the perpendicular line, sometimes they want the parallel line. Why does that matter? The slopes of perpendicular lines are opposite reciprocals. Slope will be opposite reciprocal to the one they gave us. In this case, it's -1/2. The slope they gave us was -1/2, so we'll do that in just a sec. Now remember, we want to write the equation for our perpendicular line. We need the slope, we need the y-intercept. Let me write that down as like a strategy that we can use for all these types of problems. We need the slope, we need the y-intercept, the b number. M and B. Now, M is pretty fast to find. Either we're going to steal the slope they gave us and use it, or we got to find the opposite reciprocal of the one they gave us. Depends on if we're doing parallel or if we're doing perpendicular. So we're doing perpendicular this time. So the slope they gave us, they provided, is negative 1/2. Opposite reciprocal of this is our slope. So flip the fraction 1/2 and change the sign. Positive instead of negative, 2/1. Simplify that for me. Instead of writing 2/1, we're going to say 2. So the slope we'll need today for this question is 2. Opposite reciprocal of the one they gave us. Why are we doing opposite reciprocal? Because we're doing perpendicular. Okay, we still don't know b, just like last time. So how do we finish this business? Go to your blank generic version of y equals mx plus b. Now, we just found the correct slope we're using, 2. What are we going to use for x and y? Our line is supposed to go through -4, -1. So there's our x and our y. -4 is x. Y is -1. Well, hallelujah. I think at least we don't have a fraction this time. So simplify and solve for b. So we want to basically get b all alone in this equation. So you're going to multiply 2 times -4, -8. Now, clear that -8 out away from b. We're going to add +8 to both sides. -8 plus 8 cancels, right? -1 plus 8 is +7. And there's our b. Now we just put it all together to write the equation. Y equals mx plus b, but our m is 2 and our b is 7. So when you get a problem like this, we should be thinking, okay, do I use the slope they gave me or do I use the opposite reciprocal? Look for the key words. Here it was perpendicular, so that should tell you I want the opposite reciprocal slope. So that's when we did this work on the left side to find the slope we'll be using. We flipped and changed the sign for -1/2. Then we go to our generic formula for a straight line, y equals mx plus b. We plug in the slope we're using, 2. We plug in the x and y. They provided the x and y as -4, -1. We solved for b. What we just found was a y-intercept. So b equals 7, that's not the answer. That's not the equation of the line, right? That's just where our line crosses the y-axis. We put those two ingredients together at the very bottom to write the equation. Y equals 2x plus 7. Okay, I'm going to do one more example, and this is from the Edmentum Mastery Test. Tomorrow, I want to do more of these with you, and then we'll assign the Mastery Test. Okay, here we go. Let's do one more. A little different, but we're going to use the same ideas, okay? Let's read it together, and then we'll try drawing a picture and try solving for the answer. So this says line AB. That's how we read that. And line BC form a right angle. Right angle at point B. If a is equal to -5, -2, that's the point of a, the coordinate, and b is equal to 6, 3, what is the equation of BC? What is the equation of the line BC? So they're asking us to write the equation in this format, y equals mx plus b. We need, just like the last two examples, we need the correct m and the correct b. We need those numbers. Okay, again, this time they told us AB and BC at the top are forming a right angle. So that means AB and BC are perpendicular and have opposite reciprocal slopes. They did not give us the equation for AB. That's how we did the last two examples. They gave us the equation, right? They gave us the slopes to work with. So this time, they only gave us 2 points. So we've got to find the slope of AB. Let's try to draw a picture to make sure we know what's happening. So AB and BC form a right angle, and then A lives here and B lives at 6, 3. So let's see what that looks like. It's just a quick sketch. -5, -2 is A. Right here. And then B is 6, 3. So 1, 2, 3, 4, 5, 6, and then up 3. Right about there. Beautiful. So this is AB. Is it perfect? No, but it gets me an idea of what's going on. And then it says that BC and AB are forming a right angle at point B. So what they mean by that is that they are crossing at B like this. And I'm off the screen. But there's BC. They don't tell us anything about C, do they? We don't know if it's above or below the AB line. It's somewhere, though. We just know that they both have point B, so that might be helpful later. They both have 6, 3. They want the equation for the BC line. So I'm going to put C somewhere so we know which one we're talking about. So I think it's pretty impossible to just tell from a sketch where what the y-intercept is for BC. So we're going to have to find the slope of AB, and then we'll solve it like the other ones. Okay, it's almost out of time, so I'm going to go through this quickly. So we need the slope of AB. Slope. How do I find slope if they don't give me the equation? Y minus y over x minus x. You're measuring up and over. That's the y minus y. Well, that's the up difference. And then the x minus x is how far over we're going. Up and over, up and over, up and over. So they gave us points. So we're going to use the A and B points to plug into this formula. So slope, let's do -2, that's y, minus 3. -2 minus 3, the two y numbers from above, over -5 minus 6. Okay, yikes. So -2 minus 3, that's down 2, and then you go down 3 more, right? So -5. -5 minus 6 will be -11. 5 over 11 doesn't simplify, but negative over negative does to positive 5/11. So the slope of AB is 5 over 11. Okay, so now it's like we have the slope of AB. We want the slope of BC. So we're going to do opposite reciprocal of 5/11. So flip the fraction, 11 over 5, and we have to change the sign. So -11/5. Okay, now I think we can finish this. We're going to go to our generic formula, y equals mx plus b. We just found the slope we'll use, negative 11 fifths. X and y, they give us 2 points this time. Which point is on the line BC that we want? Double check what they gave you. Don't just grab either of them. We need to make sure we're using one that's on BC. 6, 3 is on BC, so we'll use 3 for y and 6 for x. All right, and that's plus b, not 6 there. Okay, some fraction work. 11 fifths times 6. So we're going to multiply 11 times 6. That's 66 fifths, negative 66 fifths. Now we're going to add 66 fifths to both sides. On the right side of the equation, they cancel. And we're left with just b. On the left side, we've got to do the adding. So 3 plus 66 fifths. Now, again, we have to have the 3 be a fraction over 5. So I'm going to multiply 3 times 5 over 5 like this. And we get 15 fifths plus 66 fifths. All right, and then add the 15 and 66. What is that? 81, 66 plus 15. 81 fifths is B. And now finally, we can write the equation of BC. Remember, y equals mx plus b. The slope we used was negative 11 fifths. And the b we used or found was 81 over 5, 81 fifths. Okay, sorry, I got to cover up the screen here quick. Okay, Manaya, Aaron, Braden, Antonio, Andrew. Keegan, Maria Celeste, Manaya, and Sella. Okay. All right. Now, if you want to try the mastery test, you can, but I'm not going to assign it to you guys until tomorrow. There's still a little more work that we should probably do to get ready to do the mastery test in Unit 7, okay? The first one.
Hey, Josiah, when are we taking this test?
It's going to be in probably 2 weeks.
Okay.
Yeah. But tomorrow, I want everybody trying the mastery test, okay? Today, we just did 3 problems. The first 2 were to kind of get warmed up. And then this one is something you could see on the actual mastery test. And there's more. There's some more that are even a little more complex. Same ideas we used today, but a little more conceptually. So I wanted to kind of warm up to it. Was there another question? No. All right, it's 11 o'clock. So I'm sorry we didn't get a little more done today, but that is what I did want to cover with you guys. So I hope you got that written down. I am recording, and I'll have this video up later this afternoon if you want to see it again. Tomorrow we'll finish this lesson, slope of parallel and perpendicular lines. Have a good day, everybody.
Thank you.
Thanks, Maria Celeste.
Okay, bye.
Bye, Aaron.